Let's see question 11. So question 11 is application for exponential functions. Right? So this is how financial institutions calculate interest for your investment. So we either use this formula or this formula. Actually, both of this function of t. Function of t. So the first one, so let's go over those variables. So A represents amount of money after t years. So we see t appears in the exponent. That's why I make this exponential function. And P represents the principal, the money you invested in it. And then multiply by the parentheses 1 plus R is the annual interest rate. And the N is how many times the institution calculated the interest, then added to your principal, which means a compound. So compound means the financial institution calculate the interest for your principal according to the interest rate, according to how many times the interest being calculated in a year, then added to your principal. So it becomes a principal for your next year. So each year your principal increases. So that's why it's called compounded. If it's compounded annually, that means N equals to 1. So N is here in the denominator, R divided by N. N is compounded how many times in a year? If it's compounded annually, that only means once. So once in a year, N equals to 1. Compounded quarterly, N equals to 4. Compounded continuously going from the infinitesimal time. So we use this function. So A of t equals to P times E raised by RT. P is still the principal. E is called the Euler number. So the definition of E, Euler number, is a limit. So you will learn this when you go to calculus class. N approaches to infinity of 1 plus 1 over N raised by N. Okay, 1 plus 1 over N raised by N. So we see this in this formula, in the first one, right? This is the 1 plus R over N. So the numerator, so R over N can be written as R times 1 over N. Then parentheses is raised by N times T. So we do see 1 plus 1 over N raised by N is hidden in this formula. But when N goes to continuously, so that's the infinitesimal. So every second, you could think of it is the interest rate is already being calculated and is already being added to your principal. So this is a finite world. So N is a number. But when we go continuously, it's no more N. N is not, so N goes to infinity. Right? So this is the definition of E. And then if you press into calculator, the approximation is 2.718, It's an irrational number, just like a pi. All right. So when compounded continuously, so we're using the second one. A of t equals to P times E raised by RT. You see this in the exponent will have an interest rate R times T. So those two formulas are different. In the first one, we have N times T because we have N is a number. So the exponent is N multiplied by T. But the second one, we don't have N anymore. N is a part of E. We have E raised by R times T. All right, so let's just apply these two formulas for A, B, C, D. So A is given P equals to 3,000. Annual interest rate equals 4.5%, which is 0.045. Right? Compounded annually means N equals 1. For 12 years, that means T equals to 12. So we want to find accumulated value of the investment. So amount of money after 12 years. So that equals to principal 3,000 multiplied by 1 plus interest rate is 0.045 divided by n. N is 1. Then raised by n times t, 1 times 12. So we simplify this, we get 3,000 times 1.045 raised by 12, right? Then you can press into your calculator. So you press 1.045 raised by 12 first, then you multiply by 3,000. Okay, so B, let's see. So A of 7 years, so times the 7 years. So A of 7 equals to 18,000 times 1 plus 2% is 0.02 divided by compounded quarterly. So there are 4 quarters in a year, so we divide by 4. Then raised by n times t. N is 4, t is 7. So we simplify a little bit, we get 18,000 times 1 plus 0.02, that becomes 0.01 divided by 2, or 0.05, right? Raised by 28. So you can also, right, so this, let me simplify one step further. Times 0.01 divided by 2 is 0.05 raised by 28. So press into calculator 1.005 raised by 28, then multiply by 18,000. Right. So I leave this for you to do it. So let's see. C is compounded continuously. So we have a of 3 years. So T equals 3 equals to 7,200 multiplied by E, the number E. So on any calculator, there is a button for E, for all the number. Raised by R, the 6.6%, which is 0.066, multiplied by 3. All right, simplify a little bit, it's 72,000 times the E raised by 0.198. Right, 3 times 6 is 18, yeah, 198. So you can press into calculator E raised by 0.198, then multiply by 7,200. Okay, then you can approximate it to cents, right? You leave 2 decimal. You leave 2 decimal places, because when we count money, we only count it to cents. So let's see D. D also compounded continuously. So we want to find amount of money after 2 years. So the investment is 2,800. Then multiply by 1 plus the interest rate is 3.9%, which is 0.039. Oh, what I'm doing, because this is compounded continuously. It's 2,800 multiply E raised by 0.039 multiplied by 2. All right, so simplify a little bit, 2,800 times E raised by 0.078. So you can press into calculator E raised by 0.078, then multiply by 2,800. Then it'll give you approximate value. You leave decimal places in 2 decimal places. All right, so this is a life application for exponential functions.